Volume 1, Unit 7, Chemical Kinetics, page number 226. For a first order reaction, A gives B, the rate constant is x per minute. If the initial concentration of A is 0.01 m, the concentration of A after 1 hour is given by the expression 1 into 10 power minus 2 e power minus 60x. A zero order reaction X gives product with the initial concentration 0.02 m as a half-life of 10 minutes. If one starts with concentration 0.04 m, then the half-life is 20 minutes. Among the following graphs showing variation of rate constant with temperature T for a reaction, the one that exhibits a heterogeneous behavior over the entire temperature range is B. On left side you have log K, in x-axis 1 by T. For a first order reaction, A gives product with initial concentration x mole per liter as a half-life period of 2.5 hours. For the same reaction with the initial concentration x by 2 mole per liter, the half-life is 2.5 hours. For the reaction 2NH3 gives N2 plus 3H2 if minus dNH3 dt is equal to K1NH3, dN2 by dt is equal to K2NH3, dH2 by dt is equal to K3NH3, then the relation between K1, K2, K3 is 1.5 K1 is equal to 3 K2 is equal to K3. The decomposition of phosphine on tungsten at low pressure is a first order reaction. It is because the rate is proportional to the surface coverage. For a reaction rate is equal to K acetone power 3 by 2. Then unit of rate constant and rate of reaction respectively is mole power minus 1 by 2, L power 1 by 2, S power minus 1, mole, L power minus 1, S power minus 1. The addition of a catalyst during a chemical reaction alters which of the following quantities? Activation energy. Consider the following statements. Correct statements are: rate constant K is equal to collision frequency A if EA is equal to 0. In a reversible reaction, the enthalpy change and the activation energy in the forward direction are respectively minus x kJ per mole and y kJ per mole. Therefore, the energy of activation in the backward direction is x plus y into 10 power 3 joule per mole. What is the activation energy for a reaction if its rate doubles when the temperature is raised from 200 K to 400 K? 2.305 kJ per mole. If some compound gives this product, this reaction follows first order kinetics. The rate constant at particular temperature is 2.303 in 10 power minus 2 per hour. The initial concentration of cyclopropane is 0.25 m. What will be the concentration of cyclopropane after 1806 minutes? 0.125 m. For a first order reaction, the rate constant is 6.909 per minute. The time taken for 75% conversion in minutes is 3 by 2 log 3 by 4. In a first order reaction, X gives Y if K is the rate constant and the initial concentration of the reactant X is 0.1 m, then half-life is ln2 divided by K. Predict the rate law of the following reaction based on the data given below. 2A plus B is equal to C plus 3D. Reaction 1, 2, 3, 4 is given. A minute, B minute, initial rate is given. Answer is rate is equal to K into A into B power 2. Assertion: rate of reaction doubles when the concentration of the reactant is doubles if it is a first order reaction. Rate constant also doubles. Assertion is true but reason is false. Rate constant of reaction is 5.8 into 10 power minus 2 per second. The order of the reaction is first order. For the reaction N2O5 gives 2NO2 plus half O2. The value of rate of disappearance of N2O5 is given as 6.5 10 power minus 2 mole per liter per second. The rate of formation of NO2 and O2 is given respectively as 1.3 10 power minus 1 mole per liter per second and 3.25 10 power minus 2 mole per liter per second. During the decomposition of H2O2 to give dioxygen, 48 gram O2 is formed per minute at certain point of time. The rate of formation of water at this point is 3 mole per minute. If the initial concentration of the reactant is doubled, the time for off reaction is also doubled, then the order of the reaction is 0. In a homogeneous reaction, A gives B plus C plus D. The initial pressure was P0 and after time it was P. Expression for the rate constant in terms of P0, P and T will be K is equal to 2.303 divided by T log 2 P0 divided by 3 P0 minus P. If 75% of the first order reaction was completed in 60 minutes, 50% of the same reaction under the same conditions would be completed in 30 minutes. The half-life period of a radioactive element is 140 days. After 560 days, 1 gram of element will be reduced to 1 by 16 gram. The correct difference between first and second order reaction is that half-life of a first order reaction does not depend on A0. Half-life of a second order reaction does depend on A0. After 2 hours, a radioactive substance becomes 1 by 16th of original amount, then the half-life in minute is 30 minutes.